Okay, as I've said before, the bulk of this chapter has to do with quadrilaterals. We've spent the last two lessons talking specifically about parallelograms. Today's lesson has to do with special parallelograms. If you already know what is true about a rhombus, rectangle, and square as far as its definition goes, then perhaps you don't need those diagrams from the screen in your notes. If, however, the prospect of saying that a square is in fact a rectangle kind of blows your mind a little bit, you probably want the diagrams so that your mind gets unblown a little bit. So based on the markings I have on my screen, a rhombus is a parallelogram with what? What's special about a rhombus? What's the markings? Yes, a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with what? What do you notice about its markings? 4 right angles, yes. Another observation that you might end up seeing is that there are 4 congruent angles. And I already mentioned that a square is a rectangle. What else is a square based on its markings? It is also a rhombus. So a square is a parallelogram with 4 congruent sides and 4 congruent angles. And whatever is true about a rhombus and a rectangle is also true in a square. It is a square. It is a rhombus and a rectangle. And let me forewarn you, please, I am not giving you any properties of a square. I'm giving you properties of a rhombus, and I'm giving you properties of a rectangle. And I expect that you would be able to make the connection that when we're talking about a square, everything that's true about a parallelogram and a rhombus and a rectangle is true in a square. Let's take a look at some examples. Starting off very, very simply. In problem 1, based on the markings, what is this? It is a square. And what about the markings drew you to that conclusion? Right, if I have, notice, in the question, I am told that this is a parallelogram. That is tremendously important that you realize that for most of these problems where they're asking you, what is this? They're telling you that it's a parallelogram, and they're asking you, above and beyond that, what is this? Okay, so if I know that it's a parallelogram, I know that its opposite angles are congruent. So if angle F is a 90-degree angle, then it should just make sense that angle H is also a right angle. Similarly, since F and J are consecutive angles of a parallelogram, I know they will be supplementary. So I can use that to conclude that angles J and G are also right angles. So if angle F is a right angle, all angles are right angles. Okay, but that would make it a rectangle. What else did you notice, Haley? Right, I know that since FJ and HJ are congruent, bless you, and I already know that this is a parallelogram, I can use that to conclude that all of the sides are congruent. come back to this screen where I had drawn the rhombus. Now, of course, you can see my diagram isn't perfect, but I try to draw them close enough that if I add something to this diagram, you might have a hunch about what's happening with these diagonals. Now, make sure that you're not stating the obvious. In other words, I already know that this is a parallelogram. So I already know that the diagonals bisect each other. That's a property of a parallelogram. Is there anything else interesting that you think might be true about the way these diagonals are intersecting? They're intersecting, ladies and gentlemen, to form a right angle. One of the properties of a rhombus is that the diagonals are perpendicular. Another property of a rhombus, and you'll see it in your notes, it gives you a hint, diagonals of a rhombus bisect something. But I already told you, don't state the obvious, don't state that they're bisecting each other. What's happening is that they're bisecting the opposite angles. So if you drew the diagrams at the beginning of our lesson, you might want to add in the additional markings that I've put here so that you know what else is true about a rhombus. And again, same idea with the rectangle. It's not perfect, but I'd hope that it's close enough that when I draw its diagonals, you might have a hunch about a relationship that exists between them. Any hunches? Something about the diagonals of a rectangle can be completely different than the diagonals of a rhombus. The diagonals of a rectangle are congruent. So again, in your notes, if a parallelogram is a rhombus, then the diagonals are perpendicular and the diagonals bisect opposite angles. If the parallelogram is a rectangle, then the diagonals are congruent. So in problem 2 of your notes, angle 1 is easy. What's angle 1? 100. Remember, opposite angles of a parallelogram are congruent. So angle 1 is easy. How about angles 2 and 3? Don't give me an answer, give me a process. Angles 2 and 3. Any thoughts on how I'm going to find angles 2 and 3? Mariah? Okay. What is this x that you're referring to? Say that again? Angle 2 by itself? No. Angle BAD plus 100 will have to equal 180. Notice that they're consecutive angles of the parallelogram. So I know that the measure of angle BAD is 80. Look at angle BAD. Look at angles 2 and 3. Remember one of the properties of a rhombus. Right, angles 2 and 3 are congruent. So what am I doing with this 80 to find the measure of each one? Divide it by 2, yes. So the measure of angle 2 equals the measure of angle 3 equals 40. Pretty straightforward stuff, I would say. Problem 3, I have a rectangle. Notice the measurements that are given to us. We are given PN and MO, and they're the diagonals of a rectangle. Tell me again. Oh, look, it's still right there on the screen. The diagonals are congruent. So our equation is 7x minus 8 equals 4x plus 10. So 3x is 18, and x is 6. And I solve for x so I can walk away from my board and say, do the your turn, right? Is that for problem 3? Am I done with problem 3? No, there's this Clouse. Get back up there and do what? Plug it in, yes. Yes, plug and chug, absolutely. I'm asked for PN, so that was 7 times 6 minus 8, giving me 34. And now I can walk away from my screen and say, go forth and do the your turns for problems 2 and 3. Okay, based on what I'm seeing and hearing, you're ready to check your work against mine. The way I did number 2 may be different than the way you did number 2, but we should still be ending up in the same place. All of the angles in number 2 equal 38 degrees. Okay, for the your turn problem 3, it's just like the problem 3 that we did together. I set the 2 diagonals equal to each other. The copy quality in your paper is really bad, so you may have accidentally done 2x minus 13. Could that be what went wrong? Yeah, copy quality was really bad. So, okay, so fixing that minus to a plus, you're now ending up where I am. You're good? Okay, as we're finishing up getting from this screen what we need, as I said, the second part of our lesson is just that first part flipped around. So remember that Thursday's lesson had to do with how can I prove that a quadrilateral is a parallelogram. And it was just the converses of those properties of parallelograms. Same exact thing applies in the second part of our lesson. In the first part of our lesson, remember I told you that if a parallelogram is a rhombus, then the diagonals are perpendicular, and then the diagonals bisect the angles. It's very important. Even though the if had the phrase is a parallelogram, and I'm flipping the statement around, that it is a parallelogram stays in the if part. Once again, let me stress to you, you must already know that the quadrilateral is a parallelogram in order to use these properties. Okay? We have from the screen what we need? So once again, even though these properties boil down to the converses of our 3 properties from the first part of the lesson, you must already know that it's a parallelogram before you use these properties to determine that it's a special parallelogram. Okay, so same things apply. If the diagonals of a parallelogram are perpendicular, if the diagonals of a parallelogram bisect the angles, then I know it's a rhombus. And then if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. And I know some of you may be thinking I'm making a big deal out of something that might not be a big deal. However, it is a big deal because there are other quadrilaterals for which the diagonals are perpendicular. There are other quadrilaterals for which the diagonals bisect angles, and they're not actually parallelograms, so they wouldn't be rhombi. Okay, same thing goes with the diagonals being congruent. There are other quadrilaterals for which those diagonals are congruent and they're not parallelograms, so I know they're not going to be a rectangle. So again, you must already know that it's a parallelogram. And you'll notice in the instructions, they are telling you that it's a parallelogram. Okay, so you're safe. So in problem 1, I know that it's a parallelogram. And then in addition to that, look at the markings in part A. Is that a rhombus, rectangle, or square? Notice the markings. Say that again with more. It's a rectangle. As far as explaining, the diagonals are congruent. How about part B? I already know that this is a parallelogram, and then on top of that, I have that 90-degree angle. So it is a rhombus. Again, because the diagonals are perpendicular. It's not looking so bad. Not, oh my God, 2 lessons in one day. No, it's really not. Do we have from this screen what we need? No, we weren't ready for that. All right, in problem 2, I'm being asked, what does x have to be in order for this parallelogram to be a square? And I only have this 6x plus 6 as a measurement in my diagram. Yes, Daria? Absolutely. Because remember that a square is in fact a rhombus. And in a rhombus, those diagonals need to be perpendicular. So 6x is 84 and x is 14. Did it want me to plug that back in somewhere? Nope. Just what is the value of x? It's just using a property of a square. And like I said, Mrs. Clouse, you didn't give me any properties of a square. However, I told you anything that's true about a rectangle or a rhombus is true in a square. Well, a rectangle tells me that the diagonals are congruent, doesn't tell me anything about that angle. A rhombus, however, tells me that those diagonals are perpendicular, and I need to make the connection that means it's a 90-degree angle. Okay, finally, your turn for problem 2. Again, your copy quality is bad. Please make sure that you're looking at my screen to notice where there's a plus and where there's a minus before you go setting up and solving your equations. Please check your answers against mine. Make sure things are solving as they should. And I think I activated a daily quiz on Socrative. If not, I'll be doing it shortly. So please make sure you're doing that, and I'll be putting the book on the screen as well. There's books on the shelf that you're welcome to. Oh.